We are now on block 3 from topic 8 on page 235 in our workbook. So yesterday we looked at some scales that stayed balanced, and they hid some cubes in the cups, and we needed to figure out how many cubes they hid in the cups. But do we always have scales in front of us?
No.
To use?
No.
No. So I need possibly an easier method that I could use to help me solve a problem. I could, this says 2 cups plus 3 blocks equals, Hunter, 15. They're going to say the same thing, but with these squares and rectangles. 2 cups plus 3 blocks equal 15. Do you see how it's the same?
Yes.
Would this be easier to draw than the picture?
No.
Yes, it could. It's still kind of annoying. That's why I showed you my story yesterday that we could use. So number 1, we need to, I don't have number 1 here. Number 1, it says we need to sketch what these cubes represent. Well, obviously the rectangle, you're going to have a rectangle with a positive x, a rectangle with a negative x, then a square with a positive 1, then a square with a negative 1. You're drawing that for number 1. That's what our shapes stand for. Right by the speaker. All right. So, number 2, they want us to sketch out the problem 2x plus 3 equals 15. So I need to sketch it out with those blocks. So how would I sketch a 2x? Rectangles or squares? How many rectangles? 2. So I'm going to draw 2 rectangles. Okay, then I need a plus 3, so what do I draw for that?
Negative 3.
I'm just drawing right now. 3 squares. Just drawing the equation right now. So 3 squares, a dashed line means equal. And what does it equal?
3.
15.
15. So how many squares or rectangles?
Rectangles.
Squares. I need 15 of those drawn. So would this be fun working a problem like this every time?
No.
No, that's where my story that I taught y'all yesterday could help out. But I'm going to show you how this works. Then you can start just using my story, unless this helps you. So finish drawing that for number 2. Okay, I'm going to work my story the same way over here with the equation. I'm going to work it. 2x plus 3 equals 15. So first thing in my story, is X married?
Yes.
Yes. Who's it married to?
2.
2. Does X have any kids? Who's
Yes.
its kid?
3.
3, and it's positive attitude.
Doesn't have 3 kids.
Okay.
Kids 3.
Who needs to leave first?
3.
3 needs to leave. How do I move the 3?
Negative
Subtract 3 or negative 3.
Yeah, you'll cut it all out.
I'm left with 2x equals what?
12.
12.
Negative 12.
Really?
Will you
Positive
switch?
15.
You put it to the other building.
I put this to the other building. That's why it's opposite.
So 12 still like on the left.
15's bigger, so it's positive. Okay? So what's happening with my... Got 2 things happening here. What's happening over here is when I subtract 3 from this side, I'm also subtracting 3 from this side. So we need to cross out 3 on each side. Okay? If I continue with my story, I would divide by 2,
Which is 6.
x equals 6. That's with my story. So I know the answer equals 6. How does it work over here? My x bars tell me how many circles I need to separate these into equally. So how many circles do I need to make?
12.
This tells me how many circles, the x bars.
2.
So I need 2 circles and split them up evenly. How many is in each circle?
6. So x equals 6.
So x equals 6. There's 2 different methods for solving that problem.
Do you want to try both?
Yep. Okay. Why did I draw a line out right here on this positive 3 negative 3?
Because they cancel out.
It cancels out. What does it mean to cancel out?
They both go to 0.
Turns to 0. Because what's a positive 3 and a negative 3?
0.
0. That's why I'm able to draw a line. Okay, I want to skip to problem 4. In problem 4, I have some properties written in the chart that you need to write down real quick. And then I'm going to solve these problems. So the first one is subtraction property of equality. Next is addition property of equality. Next is division property of equality. And the last one is multiplication property of equality. Then I'll explain what they mean. All right, so looking at the first equation, is X married?
No.
No. Does X have children?
Yes.
Yes. Positive or negative children?
Positive.
Okay. So I need to move the kids. How do I move the kids?
Send them to the counselor. You gotta send them to
Yeah.
the counselor.
How do I move them over there? Subtract
Negative.
3 or negative 3.
Now you that smart.
Cancels that out. X equals, I have a positive 5 and a negative 3, which gives me
2.
positive 2. X is by itself. So why did they call it subtraction problem?
Because you subtract.
You had to subtract to solve it. What does equality mean?
To equal.
Equal. The U.S. is
Equal.
equal. There's equality among the citizens, or should be.
Yeah.
Okay? So, equality, everybody has to do the same thing. So, both sides of that equation had to subtract. So that's why it's called the subtraction property of equality. Okay, moving to the next one, is X married?
No.
No. Does X have any children?
Yes, it has a -3.
-3. How do I move that over?
You addition.
Add 3 or a +3.
How you do that?
X is alone, and X equals what?
11.
11. Why did they call it addition property?
Because you ended up adding.
You added both sides and didn't leave anybody out. Okay? Next, is X married?
Yes, sir.
Who's it married to?
Yes. 4.
Three. 3. Does X have any kids?
No.
I mean, yeah.
No, it has no children.
Yes, it
No.
does.
Is anything added or subtracted to the X?
No.
So there's no kids. Okay, so I need to break up what operation is 3 and X doing?
Divide.
Right now,
Multiplying.
multiplying. Opposite of multiplication is
Divide.
division. Who's getting kicked out?
X.
Nothing.
X never leaves. X equals, what's a
Five.
negative?
5.
15 divided by
Negative
3.
Five.
Negative 5.
Is it because the 15 is a bigger number?
Nope. Multiplying, it doesn't matter. One negative is a negative number.
You were dividing,
Adding or
Seth.
subtracting,
You were
multiplying and dividing.
Oh.
It takes 2 negatives to make a positive. Okay, the last one is X married.
No. Yes.
Yes.
Yes, it is.
But
What
they're
I do, Mary?
dividing.
It's very changed.
No. No, it's not.
I don't know that. I call this, you could call it a complicated relationship, maybe.
Wait, they ain't not
Just let me speak, please, because there's too much noise going to my speaker. I call it a complicated relationship. Next question I want to know is, does X have any kids?
No.
Added or subtracted?
No.
Okay. What I call this is a creeper in the basement. You see how he's in the basement on the first floor? Okay, so he's on the first floor, kind of in the basement, like a creeper, and he needs to get out. So that's kind of how I call him a creeper in the basement.
That's a pretty simple problem.
So what operation is the creeper doing currently?
Divide.
What's opposite of division?
Multiplication.
Multiplication by the creeper, which is 4. Cancels that out. I'm left with X equals
2 times 4.
2 times 4, which is 8. And there, X is by itself. Okay. Essentially, we already did problem 5. I had you write the properties in the chart. So moving to problem, let's go to problem 7. Okay, problem 7. I don't think I want you two by each other anymore. I'm rewriting the problem, and so should you. It looks kind of ugly. Alright, some people say it is ugly. There's no kinda about it. Okay? But We just learned how to solve problems like that, agree?
Yes, ma'am.
And then now they're throwing fractions at us. They're not gonna throw some crazy fractions at a 7th grader because you just learned how to do this. They're only gonna throw fractions that turn out pretty easy. Now 8th grade, they're gonna throw out some weird numbers, but not yet for 7th grade. Yes, it has fractions, but can we probably work with halves? We know how halves work. Okay, so let's establish our people in this problem. Is X married?
Yes.
To who? 1/3. Does X have any children?
Yeah.
5.
5.5. Are those children have a positive or a negative attitude? Negative. And who is the counselor? 6.5. Okay. So, who moves first? Who always moves first?
The children.
The kids.
Children.
It's a -5/2. Opposite of that is
Positive.
+5/2 or positive. That zeroes out, so it cancels out. I have 1/3 X equals, well, let's think about this. I have a half plus another half. How much do I have?
1 whole.
1 whole.
So it's gonna be less.
7. It's
Shh, hold on. I have a half. A half, so that's 1 whole. 1 whole plus 6 is 7. 7 plus 5 is 12. So all of that equals 12. Did that turn out ugly?
No.
No, because you're 7th graders and just learned how to do that. So they're gonna leave the fractions pretty simple.
So 1 whole X is hold on. 36. I didn't.
You're, yeah, people can't get there.
That's what you did.
So is X alone?
No.
No. So I need to get X alone.
Divide.
So I need to divide. Who's X kicking out?
1/3.
He's kicking 1/3 out.
Yeah.
But then that means that we're having to divide by a fraction. You're not supposed to divide by fractions. We multiply by the reciprocal, which means this is 12 times, what's the reciprocal of 3? 3 over 1, which is just 3. Oh, so that turned out to be kind of a nice problem. What is 12 times 3?
36.
Did it turn out to be crazy hard like it looked? No. They make it seem like it's going to look crazy hard, but they're not going to make the 7th grade fraction problems like this crazy hard. They're going to probably leave it as halves, even on the state test.
Like when you got the X by the 12, the 1/3 X. That's
Yeah.
all. So couldn't you just say 12 is 1, and then you got another one would be 2 over 3?
Yeah, but some people don't understand fractions as well as you're seeing them. You saw that 1/3 of X was 12. You needed 3/3 to make a whole X. And so you just kind of did that in your head. Some people don't understand fractions that well like you do. I mean, you probably essentially could have left out all that stuff.
Well, yeah, I mean,
Okay, I remember I can always check my work by plugging this back in, which, it's kind of ugly. 36 times 1 divided by 3 is 12. 12 minus 5.5 is 6.5. So I got it right. Okay, next problem I want to look at is number 8B. Is that 8 next?
Yes,
B?
ma'am.
I want to look at 8B. And this is wait. Oh. Okay, I knew the answer is X equals 36, right? Okay, I'm going to show you a different way to solve this because I don't like dealing with fractions. Do you like dealing with fractions?
Yes.
No.
Sometimes.
Okay, so I'm going to back this up. Okay, and I am going to show you how to get rid of fractions. The first step in getting rid of fractions in a problem is change everything to a mixed improper fraction. Thank you. So I'm changing this to 1/3 x minus, that's going to be 11/2, right? Equals 13/2. Everyone with me?
Yeah.
You might want to write this. If you want to have a trick, you can write it down at the bottom or somewhere. And then save this page for the rest of your life because it will be helpful. Okay? I changed everything to improper. Now I'm going to do the step of getting rid of fractions so I don't have to deal with them. It's hearing you over me because you're closer, so stop. To get rid of fractions, you have to multiply the whole problem by the least common multiple of the denominators. Least common multiple. Okay, so my denominators are 2 and 3. What is the least common multiple of those?
2 and 3.
Can
Six.
2 times something make a 3? No. Can 1? Least common multiple. So multiples of 5 is 5, 10, 15, 20. Multiples of 4 is 4, 8, 12. Okay. 6 is my least common multiple. Can 2 make a 6? Can 3 make a 6? So 6 is my least common multiple. By me finding that and multiplying the problem times the least common multiple, I will no longer have to deal with fractions. I'm going to do 6 times the top divided by the bottom. 6 times 1 is 6. 6 divided by 3 is 2. The fraction is gone. 6 times 11, 66. Divided by 2 is 33. 6 times 13 is
Wait, hold up. I want
78.
What's 3 times
Yes.
78 divided by 2 is 39. Do I have any fractions now?
No.
That will be very helpful for your math future. That's what, not knowing how to do that is what got me close to failing some of my math classes in high school and college.
Wait.
I even did fail some of them. Okay? All because I didn't know this trick. When I figured it out in college, I knew everything now. Everything made
That's
sense.
a different answer.
It was 36.
Nope.
Yeah, it was 36.
Okay? I'm going to solve this the same way. I get 2x equals 72. Divide 2 by 72 by 2. X equals 36. Isn't that what I got last time?
Yeah.
So you get the same answer, but don't have to deal with the fractions. I got rid of the fractions by multiplying by the least common multiple. I have one more problem, 8B. 8B has decimals. I was never very good with decimals, but when it comes to dividing them. So I had to figure out how I could work around that. So how many decimal places does 11 have? None. How many decimal places does 2.5 have? 1. How many decimal places does that have? 2. What was the greatest number you just told me? 2. Number of decimal places. Greatest number of decimal places was 2, right? So I'm gonna back up every decimal 2 jumps. Well, where is 11's decimal right now?
0.
At the end. I'm gonna back it up twice. I'm gonna back 2.5's up twice, and that's gonna give me 250x. I'm gonna back up 4.75 twice and 475. Now there's no decimals, and I can work my problem. Okay, so what would I need to do first here?
You take the children.
Move the children how?
You make them a negative. Or
I
you subtract.
negative or subtract them. Cancels that out. This turns to 625 equals 250x. X wants to be alone. So who's he kicking out?
250.
How is he kicking 250
Make
out?
it a negative or subtract.
What operation is going on?
Multiply.
Multiplication. Opposite of multiplication is division. So I divide by 250.
Cancel.
I'm left with x equals,
That's a
it's
fraction.
gonna be a fraction because
It's gonna be 2 and something.
2 sets of 250 is 500. Another 250 is 750. I went over. So I need 2 point something. 2.5. 2.5. 625 divided by 250 is 2.5. And there's my answer without having to deal so much with the decimals. Okay, the homework for this section is problem 10 through 12. Homework is not going to be checked until Friday, but I'm checking block 1, 2, and 3's homework Friday. All right. Thanks for listening. Have a great day. Like, subscribe, hit the notification bell, and peace out, home dogs.
Bye.